In episode 2, the circuit and script were worked out to create a flickering light effect with AC voltage and household lights. Now it's time to reduce the size, make it more permanent, and package it up. Working with electricity is dangerous and can cause serious injury or death if done improperly. Always use caution. First off, to minimize the overall size of the circuit, I'm going to move from the Arduino Uno to the Nano. I'm hoping that, and expecting, I can upload the Uno script into the Nano as they are very similar. In the Arduino IDE, I'll change the board type to Nano, check and select the correct COM port, and upload the script. I'll swap out the Uno for the Nano. Once swapped out, I'll confirm the operation. Just as a reminder, don't forget to subscribe. Click like if you do, and the notification bell for new videos. And if you have comments, please leave them below. Now that the operation is confirmed, I can start designing the printed circuit board. One thing I'm going to do is replace the BT136 triac with a BT138 as it can handle a maximum of 12 amps RMS. The BT136 has a maximum current of 4 amps RMS. With the increased current, I need to make sure that the traces on the PCB can handle it. I found a website that assists in calculating the width and the thickness required for the current. The link is in the description. Once the PCB design is complete, I'll send it off for manufacturing. The product looks good. The thickness of the traces are quite substantial, so I'm confident that it should be able to carry the current up to the triac's capacity. With the empty PCB, I'm going to position it in the chassis so that I can mark the mounting points. Now to populate with components. Now that that's done, I'll install the Nano into its socket. And connect the 10-volt AC transformer. And like in episode 2, I'll use the variable voltage regulator again and connect it to the PCB. Connect the lamp connector, and turn on the power to the circuit, and then confirm that the variable voltage regulator is adjusted to 0 volts before turning it on. Setting the light level to 50%, surge to 50%, and the flicker depth to full and frequency to maximum. And slowly turn up the AC voltage and confirm that there are no issues. Now for the chassis work. I'll use a butchered IEC cable and directly connect it to both the primary of the 10-volt transformer and the power terminals of the PCB. For the lamp load, I'm going to use the BX cable and quad box I used during testing. Now that it's all assembled, I'll do a final test. In the next episode, I'll connect multiple lights and test the effect on a larger scale.